Okay, now we're given another one-to-one function, and our goal here is to find the inverse, but this is a little bit messier because there are two x's on the right. We will begin by dropping the v of x notation and rewriting this as y equals x minus 5 over x plus 1. And as you know now, we want to switch the x's and y's. So that'll be our first thing we're going to do. Instead of y equals, we will have x equals, and the right side will become y minus 5 divided by y plus 1. Okay, at this point we now want to solve for the new y, but we've got y's showing up in two places. So our goal is to kind of clean this equation up a little bit. I'm going to put the left side over 1, and then I'm going to cross multiply. The first or main diagonal gives us xy plus x, and the other diagonal with the 1 in the bottom left corner would give us 1 times y minus 5, which is y minus 5. We now want to isolate the x on one side of the equation, so I'm going to subtract the y off of each side and bring it to the left, and subtract the x off of each side and bring it to the right. Now we will have xy minus y on the left and negative x minus 5 on the right-hand side of the equation. Then, to get the y together in one place, we will factor it out of the left and have y on the outside times x minus 1 on the inside, and on the right we will have negative x minus 5. We can then get the y by itself by dividing off the x minus 1 on each side. This will give us y equals negative x minus 5 all over x minus 1. Now that is one way to write this, and so we could have f inverse of x equals negative x minus 5 over the x minus 1. Or we could factor that negative out of the numerator and have negative out front, x plus 5 over x minus 1. Or you could move that negative down into the denominator, which would make negative x plus 1, which could be rearranged as 1 minus x with the x plus 5 upstairs in the numerator. So any of these three forms of the answer are perfectly fine. Now let's try this with another type of function. Find the inverse, but notice they've restricted this to the right side only. If you were to take a look at the graph as they're suggesting, basically you have a V-shaped graph here at negative 3, and we're defining it with only the graph on the right. So we're only going to have this right-hand arm of that absolute values and nothing on the left. Okay, we need that when we look at the rest of this problem. We begin with y equals the absolute value of x minus 3, and we do our variable switch as we're getting used to doing. This will become x is equal to the absolute value of y minus 3. Well, we want to isolate the absolute value before we remove the absolute value, which means we need to add 3 to both sides, and we will have x plus 3 is equal to y. Okay, let's keep on going with this. Whoops, the y is in absolute values. Removing the absolute values, we're going to have either y equals x plus 3, which means the absolute value really served no purpose, or y is equal to negative the x plus 3, also written as y equals negative x minus 3. Now let's take a look at both of these options. If we look at y equals x plus 3, it would have a y-intercept of 3, and it would have a slope of 1, and it will go up from there and then back down from there. That is going to be a valid answer when we look at our graph, because when you look at this here, don't we have a mirror image on both sides? So we do like this right here, provided it only starts here at negative 3 and moves upward. So we could say choice number 1 is going to be f inverse of x is equal to x plus 3, comma, where x is greater than or equal to -3. That would be one choice. Now let's look at this other option, y equals -x minus 3. This is going to have a y-intercept at -3, and it's going to go downward. Well, just looking at these, is that going to be a reflection across the diagonal line, y equals x? No way. So we're going to ignore that answer altogether and only go with f inverse of x on the left.